Welcome to this video, right prism and right circular cylinder. We will define the right prism and how it differs from the non-right prism, and we will conclude its area and volume. We will also define the right circular cylinder, and we will conclude the area and the volume. Please subscribe to the channel and activate the bell button to receive notifications for the new videos. Now let's start. So before we define the prism or the right prism, we have two notes that are important to understand this definition. Note 1 says a line is perpendicular to a plane if it's perpendicular to two lines in this plane that intersect. So here we have the blue line named L is perpendicular to both of these two red lines. From this, we conclude, based on note 1, that it's perpendicular to the plane that contains those two red lines, which is the plane M. Note 2, two planes are perpendicular to each other if one of them contains a line that is perpendicular to the other plane. So here we have the line L is perpendicular to the plane M as we have just seen here. So line L is perpendicular to the plane M. According to note 2, this means that any plane that contains the line L is perpendicular to the plane M. And in our case here, we chose this plane, the red one, we called N. This plane contains line L, so it's perpendicular to the plane M. We keep these two notes in mind as we progress to define the right prism. So a right prism is a 3D object that has a polygon as its base. So it has two bases. Each of them is a polygon. This polygon might be a parallelogram, including a rectangle, a triangle, a square, a rhombus. And the right prism has vertical sides that are perpendicular to the bases. And each vertical side is a rectangle. So here, if we look at this right prism, we notice that, first of all, it's a 3D object since it contains 3 dimensions. So we have this dimension, we have that one, and we have this dimension. And it has two bases. So we see base 1 and base 2. We can see that the bases here are parallelograms. It's not very clear whether they are rectangle or square, but I think they are just parallelogram. It doesn't show exactly that this angle is a right angle. So we consider them to be parallelograms. And we can see also the vertical sides. Here it has 4 vertical sides. This one, the first one, the second one, the third one, and the fourth one. And they are all rectangles that are perpendicular to both bases. The two bases, of course, are the same shape and size, and they are parallel to each other. So the plane that contains the base on the top is parallel to the plane that contains the base on the bottom. This kind of prism is called a right prism because the angles between the base and sides are right angles. So if we move to this prism, we notice that the angle between the vertical side and the base is not a right angle, as we see here. In this case, we say that it's not a right prism, or it's a non-right prism. Another example is the right prism we see here. we notice that the base is also a polygon with 5 sides, and it satisfies the conditions in order to be called a right prism. And here we have the vertical sides are perpendicular to the bases. However, in this prism, we notice that this angle is not a right angle, and we call this kind of prism an oblique prism. It's also, of course, non-right prism for this reason. Another thing, the height of this prism, which is the line that is perpendicular to both bases, is the same as the edge of the vertical side. However, in the case of an oblique prism, we notice that the height which we see here, this line with dashes, is not the same, or it doesn't have an equal length with the side of the vertical side here. So this is a non-right prism also. And in general, an oblique prism is a prism where the sides are not at right angles to the bases. Now we move to calculate the area of the right prism. So here we have a right prism with bases, the bases taking the shape of triangles that are equal in size and shape. In this case, if we consider this actually made of paper, we can bring scissors and cut the side area. So we get 3 parts here. Each is related to one of the vertical sides of the right prism. So here, for example, this size here is that one, is that vertical side. Okay, and this one here is this vertical side. So, and that one, of course, is related to the last one. So if we put all of these sides together, as we see here, we can find out that the side area of the right prism is equal to the sum of 2 plus 4 plus 2 multiplied by square root of 5, which is nothing but the circumference of the base. This is the circumference of the base. And this is multiplied by the width of the triangle, which is the height of the prism, or in other words, the length of the rectangles that form the vertical sides of the prism, which is this one, and is equal to 5 multiplied by 5, which is the height of the prism. And we have written this here clearly: side area of the right prism is equal the circumference of the base, which is this one, multiplied by the height of the prism, which is that one. So regardless of the type of the base we have in the right prism, but the side area of the right prism remains the same, which is the circumference of the base multiplied by the height of the prism. Now, if you want to calculate the total area, then this is equal to the side area, which we already calculated here, the side area plus the area of the two bases. In this case, the area of those two triangles that form the bases. So the total area of the right prism equals the side area plus the sum of the areas of the two bases. The volume of the right prism. So, for example, we take this right prism, we see here on the right side, and it is a right prism with bases that take rectangular shape. Now, the volume of this right prism is actually the number of the cube units that we need in order to build this right prism. So here we have a cube unit, meaning that the height is equal to the length is equal to the width, and each of them equals 1 centimeters. So how do we calculate, or how do we know how many cube units we need to build this right prism? First of all, we need to calculate the area of the base. The area of the base helps us to determine how many cube units can fit on the area. So here we have a rectangular base with length equal, the length is equal to 4 centimeters and the width is equal to 2 centimeters. So we can say that the area of the base is equal to 4 multiplied by 2, and this gives us 8 squared centimeters, meaning that the area has a space to fit 8 cubes on it. So by fitting 8 unit cubes on it, it means that we formed the first layer. So how many cubes we need to build the whole right prism? Cube units we need to build the prism. This is equal to the area of the base multiplied by the height of the prism, which is 5 centimeters, since we need to repeat the layer we fit first at the base 5 times. So multiplied by 5, which is the height of the prism, and this is equal to area of the base is 4 multiplied by 2, since the base is a rectangle, multiplied by the height, which is 5. And this will give us 40 cubic centimeters. It means we need 40 cubes or unit cubes to build this prism. As a test, calculate the side area of a right prism. Its base is a triangle. So first of all, we draw it simply like that. So here we have a right prism. Of course, this is meant to be a right angle. Okay. The length of its sides are 6 centimeters, 5 centimeters, 4 centimeters. And its height of is 7 centimeters. So here it means the sides of the triangle. So they are 4 and 5 and 6. And here we have the height of the prism is 7. So the side area, as we have seen before, equals the sum of the areas of the vertical sides. And we know that each vertical side is a triangle. So in this case, it will be, here we have the first vertical side. So we have 4 multiplied by 7, its area, 4 multiplied by 7. Now we move to the other one. We have 6 multiplied by 7. Six multiplied by 7, and the last one is 5 multiplied by 7. Okay, this one is the vertical side we are talking about, 5 multiplied by 7. And this is equal to 4 plus 6 plus 5 multiplied by 7, and it is 15 multiplied by 7, which is 105. Here we have centimeters, so it's squared centimeters. The right circular cylinder. A cylinder is a 3D object that has 2 parallel bases connected by a curved surface. These bases are like a circular disc in shape. So if we look at this cylinder here, we can see that it's a 3D object with 2 parallel bases. This is the first one, and this is the second one. And they are parallel to each other, and they take the shape of a circular disc. Also, they are connected to each other by a curved surface. The line passing from the center or joining the centers of the 2 circular bases is called the axis of the cylinder. So here we can see that this is the line that connects the centers of the 2 bases. We call it the axis of the cylinder. Here the same, we see this is the axis of the cylinder that connects the centers of the 2 bases. Now, when do we say that a cylinder is a right circular cylinder? If the axis of the cylinder is perpendicular to the bases. So we notice here that this axis is perpendicular to the bases, or perpendicular to the planes that contain the bases. However, in this case, we can see that the axis is not perpendicular to the plane that contains the base. In this case, we call this cylinder non-right circular cylinder. The distance between the 2 bases of the cylinder is called perpendicular distance and is represented as height h. So we can see here this perpendicular distance, which we call the height h, is equal in length to the piece of line that falls on the axis of the cylinder that connects the centers of the 2 bases. However, in this cylinder, which is non-right, we see that the perpendicular distance, which we call h, is not equal in length to the piece of line that connects the centers of the 2 bases and that falls on the axis of the cylinder. The area and volume of the right circular cylinder. So let's consider we have this right circular cylinder, and we bring scissors and we cut it in 3 pieces. The first piece is the first base. The second piece is the second base. We can imagine it to look something like that. And the third piece is the rectangle that represents the curved surface. So we can imagine that we use the scissors and we cut it here from the edge and then we open it. So it will turn into a rectangle. And the length of this rectangle is nothing but the circumference of the bases, of one of the bases. And the width is the height of the cylinder. So the side area of the right circular cylinder then is the same as the area of this rectangle we see here. And this is, as we see, is equal to the circumference of one of the bases, the circumference of one of the base multiplied by the height of the cylinder. Now, if we want to calculate the total area of the right circular cylinder, then we have to add the side area, which we found here in the first step, to 2 multiplied by the area of the base. So it's the side area, which is the area of this rectangle, plus the area of the first base, plus the area of the second base. Now the volume of the right circular cylinder is the area of the base multiplied by the height of the cylinder. So let's move to do an example in practice. So here we have a right circular cylinder where R, which is the radius of the base of the circular base, equal 15 centimeters. The height is equal to 40 centimeters. Now calculate its side area, its total area, and its volume. So as we saw before, the side area is equal to the area of the rectangle we get by cutting the curved surface and opening it. So it's the area, so it's the circumference of the base multiplied by the height h, which is equal to 2πr multiplied by h, that is 2p r equals 15 and h equals 40. This approximately might be equals, here we calculate and we get the area, side area in squared centimeters. Now the total area, as we have seen, it's the side area plus 2 times the area of the base. That is the side area that we have computed here, side area. Let's call this SA plus 2 multiplied by the area of the base. The area of the base is the area of the circle with radius r, that is equal to 15 centimeters. So it is now plus 2 multiplied by p multiplied by 15 squared, and this will give me an answer in squared centimeters, and Let's move now to calculate the volume. As we have seen on the previous slide, the volume equals the area of the base multiplied by h, the height. So it is the area of the base is p r squared, and this has to be multiplied by h. So it is p multiplied by 15 squared multiplied by h, which is 40. And this gives us something cubic centimeters. Thank you for watching this video.